Hello everyone. So in the studio, there were a lot of questions about how this structure, okay, that we declare, okay, in the serialization studio, how is it actually stored in memory, and how does it look like once we serialize it. All right. So I thought I'll create this video to dive deeper into this and explore everything step by step, so you understand how the elements of the structure occupy the memory space, as well as how it looks like once we serialize it. All right. So I've extracted out the main parts of the code over here, but it's the same as what we saw in the studio, where we have a structure and then we declare the three elements of the structure: the character C, the unsigned integer 32x, and the unsigned integer 32y. All right, and then we declare a variable test with the type of t data. All right, and in the setup code, okay, we also assign the values to the elements of the structure, where we say test.c is ASCII A, test.x is numerical 5, and test.y is numerical 10. Okay, and in the main code, in the loop code, what we do is we basically uh, assign the size of the t data structure to a variable, the size, and then we print out the size as well as the actual elements of the test structure. All right, so we're going to go through step by step how this whole thing works, so that we understand the behavior or we're able to better understand what we actually observe in the studio. All right, so I've commented out the second line, okay, which is the write of the entire data packet or the structure, and we're just going to focus on just writing the size. Okay, just writing the size, and I made some again some changes to the code just for us to analyze things step by step. Okay, so let me upload this code to the board. Okay, so let me clear and reset the board. Okay, so we see the value of 9 being printed out. All right, and this is again something we already know from the studio, because this is character is 1 byte. Okay, this is 4 bytes and this is 4 bytes. Okay, so all together we have 9 bytes over here. All right, so the size of this t data structure is 9 bytes. Okay, so I think that part everybody is clear. Now let's now go deeper into understanding how these 9 bytes are actually arranged in memory. All right, so if you look at it from the memory perspective, we basically have 9 bytes. Okay, so let me draw 1 2 3 4 5 6 7 8 9. Okay, so 9 bytes that are going to be stored, and what we want to do is we want to understand how uh, these elements of the structure are stored in memory. Okay, so I'm going to first print out the address. Okay, the address of the element C. Okay, because C is the first element in this structure, so that is basically the starting point of this entire structure of test, okay, within the memory space. Okay, I want to know where it's going to start. All right, so again, we will analyze it. Along the way, you'll see that sometimes the address will change because of changes to the code. All right, where this starting point may change, but the idea is still the same. The way it is arranged in memory will still be the same, but the starting point may change as we run the code along. Okay, so now let's just focus on the variable C. All right, and see what is the value that we get. Okay, so let me clear this again and reset my Arduino. Okay, so I get a value of 128 and data is 8. All right, so what does this tell me? That means, okay, so this address is printed out as hexadecimal. So this is address 128. So in address hex 128, I have the content of A inside. Okay, and this is basically the variable C. Okay, variable C. All right. So that is the starting point of my variable test within the memory space. All right. Now let's go ahead to explore where is the starting address of X. All right. And since X is the next element in the structure, it will actually start in the next address itself. All right. But we will see, okay, again from the printout, the address given. Okay. So let me reset again. And yes, correct. So as you can see, the next address is 129. So X, okay, the variable X, okay, is starting in address 129. So 0x129 is where the variable X, which has a value of 5, is stored. Okay, so what can I say? That means these 4 bytes, okay, have a value of 5. Okay, and this is the A variable. Sorry, this is the X variable. Okay, so X is occupying 4 bytes starting from address 129, and it has an address, it has a value of 5. Okay, so the 4 bytes in this case would be 0x129, 0x12A, 0x12B, 0x12C. Okay, so rightfully the variable Y would start in the next address, which should be 12D. All right, so let's just observe that again over here. Okay, so in this case we are focusing on the variable Y. All right, and let me upload the code. Okay, so let me run it again. Okay, so as expected, 12D is the starting address of variable Y. Okay, so 12D is here. So 12D. Okay, then so the next 4 bytes 12D, 12E, 12F, and then 0x130. Okay, so these 4 bytes are actually holding the variable Y, and the data is 10. Okay, so this part, I think now we are a bit clear now that this is how this structure, okay, the contents of this structure are arranged in memory. Okay, so first C followed by X followed by Y. All right, now what we want to now observe is how does the 4 bytes or how does the variable X and Y spread out across these 4 bytes. Okay, so we actually know the answer because we know that Arduino is occupying or is using little-endian mode, which means the least significant byte in the lower address. Correctly significant byte in the lower address. But let's just confirm this again with the code. So what I'm doing here is I'm now exploring X. Okay, I'm exploring X, and what am I doing here is I'm going to access from starting from X the 4 bytes. So this loop is to print the 4 bytes, the address and the data associated with the 4 memory elements from where X is stored. Okay, so let's upload this code. Okay, so right now the addresses have changed. So let me just update these addresses here. Okay, so as I mentioned before, as we change the code, these addresses may change. So right now this is 149, so this will be 14A, 14B, okay, 14C, 14D, 14E, okay, then 14F, then 150 and 151. All right, so you can see that looking at this, okay, the address 14A is 5. Okay, so the content over here is 5. Okay, this is the first uh, printout over here. Then 14B is 0, then 0, then 0. Okay, so again, this is basically what we are expecting, correct? Because this is basically your little Indian format. Okay, and as I mentioned in class, the easiest way to remember is least significant byte in lowest address. You just remember this alone is enough. Okay, because then the big Indian format is opposite. That means the least significant byte in the highest address. Okay, so little Indian means the least significant byte in the lowest address, and this is a 4-byte variable, correct? So x is a 4-byte variable. So x is, if I were to look at the 4 bytes, okay, so the 4 bytes would be 0, 0, 0, 0, 0, 0, 0, 5. All right, I'm putting it all in hexadecimal. So this will always go to the lowest address in little Indian format. All right, so that is what is observed here. So the least significant byte is in the lowest address, followed by the rest of the bytes. Okay, so we should be observing the same thing for the y as well. All right, so let's do that. Let's uncomment this. Okay, and let me upload it again. Okay, so the addresses have changed again, but again, I think as long as you understand the concept is fine. So again, you can see that the A000, A is in the lowest address, followed by the next address, next address, next address. All right, that means, okay, even though the address have changed, okay, the observation is still the same, that the value 10, okay, so 10 is ASCII A, sorry, not ASCII A, hexadecimal A. So the A comes here, followed by 0, 0, 0. Okay, so the least significant byte in the lower address. All right, so the same thing. So let me put it for you over here. So y is also 4 bytes. Okay, and the 4 bytes are 0, 0, 0, 0, 0, 0, 0, A. So A is 10. Okay, so 10 is A, and this is in the lowest address. All right, which is what you observe here. This is what you observe here. Okay, so all of this is again aligning with what we already know. So we know that Arduino is a little Indian format device, which means that a multi-byte data will already be stored such that the least significant byte is in the lowest address. All right. So now we have a very clear idea how this entire structure is stored in memory. Okay, how the 9 bytes are occupied. So when I do this, correct? So when I serialize this data, okay, when I say serial.write, and this whole data chunk comes out of the serial, what am I actually observing? Okay, so that's the last part over here. Okay, where I'm going to print out the entire data. So it's actually the entire serial.write, all right, which is similar to what you have here, but instead of a single line over here, I'm printing out just byte by byte. Okay, I'm printing out byte by byte, so you observe what is happening. Okay, so let me come here and let me clear this and run it one more time. Okay, so you can see down here that the final printout here is this value over here. So it's A 5000 A000. Okay, so basically what does it tell us? That means when I call this line over here, when I call this serial dot write with test is basically a starting address. Okay, and the starting address of this entire structure is this. Alright, and based on the size of data, which is 9 bytes, I print out the 9 bytes starting from the address of where test is in memory. Alright, so these are the 9 bytes. Alright, and it is going in the order of the address. Okay, it's going in the order of the address where it is the starting address in this example is 149, and then subsequently the next 4 bytes, okay, which is in the little-endian format, so least significant byte followed by the rest, and then y again least significant byte followed by the rest. Alright, so that is basically what you are observing or what your Arduino is sending out. Okay, so I hope it's sort of clear on how this whole thing works. Alright, and in terms of relating the structure to the memory and how it is actually being serialized and sent out on the serial port. Okay, so I hope this is clear now. If you have any questions, feel free to ask me. Okay, thank you. Bye.